All right, we got unit vectors and angles between vectors today. Take some good notes on this one. Not hard, but there's 3 or 4 things, so make sure you get it all down. Get some good notes. Get your question right at the end. All right, the first word is unit vector. A unit vector is just a vector of magnitude or length 1. And the question here says find a unit vector that has the same direction as that vector v. And here's all you do to find a unit vector in the same direction. You take the vector that they give you, vector v in this case, you find the magnitude first and you divide it by the magnitude. So what I'm going to do is I'm going to find the magnitude. Remember we did this yesterday. Square the 3, the negative 3, square the 5. Gives me square root of 34. And to get my unit vector, you divide your original vector by your magnitude. So I'm dividing both of those by the square root of 34. And remember the trick for rationalizing, don't leave a radical in your denominator. So I'm going to rearrange it, put negative 3, move the square root to the top, take it out on the bottom. That's all you got to do. Square root to the top, take it out on your denominator. There you go. Unit vector in the same direction. Now, if you were to find the magnitude of this, if you were to square this, square that, add them up, take the square root like I did up here, I promise you would get 1 because it's a unit vector. All right. New notation, when you see vector I and vector j, vector I is just 1, 0, vector j is 0, 1. All this is a different notation for the same thing. If they give you a vector in component form, like 2, negative 6 is vector r, you can also write that 2 times vector I minus 6 times vector j. This notation right here is exactly the same thing as that, written just a little bit differently, and it does have some good uses to it. We're not going to go into many of them, but just I want to show you in case you ever see that again, that you can do that with a vector. Okay, this one says a vector A is 5, negative 2, and vector B is negative 1, 8. Find 3A minus B. So I'm going to do 3 times this vector, which will give me 15I minus 6J. And I'm going to subtract from that vector this one, minus B, which B is negative I plus 8J. All right, so I'm doing 15 minus negative 1, which is really 15 plus 1. So it's going to give me 16I. Then I have a negative 6J minus 8J, which gives me negative 14J. And that's your answer right there. But please realize that's the exact same thing as this vector, 16. So it's different notation for exactly the same thing. All right, direction angles. This is a biggie. Direction angles. We want to know what direction angle this takes. Remember, that is this really. That's really negative 4, negative 3. And we talked about component form does this. Component form, the initial point's at the origin. This is going to negative 4, negative 3. So it goes to right here. So the vector looks like this. And it's asking what angle, what's the direction angle? It's basically talking about what's that angle right here, or the whole thing. What's the angle from there? So I'm going to say the way we're going to find that is, and think about this, that angle comes from going this direction and that direction. Like I know that I went 4 that way, even though it was negative. I went 3 that way. So that's opposite over adjacent. That's tangent. So I'm going to do tangent theta equals negative 3 over negative 4. And I'm going to take my calculator and punch that in. When I punched it in, here's what I got. I got 36.9 degrees. But if I'm looking at that angle, I know that's in quadrant 3. So what I need is I need the quadrant 3 angle. So I'm going to add 180 to that. 180 to the 36.9 would be 216.9 degrees. And that's my theta. That's all there is to that one. Okay, next concept is something called the dot product, and it's important, but we're going to use it to do something more important here in a second. So the dot product, all it means is not really multiplication, even though it says product. When you do the dot product of 2 vectors, like vector u and vector v, here's what you do. You multiply their x's, you multiply their y's, and then you add them together. That's all you do. And you're getting, when you do that, you're going to get one number, which means you're getting a scalar, not a vector when you work that out. So you're getting a one number answer, not another vector. Okay, so we're going to try a couple here. It says, this one says find the dot product, and the first one says the dot product of u and w. So that's these 2 right there. So all I'm going to do is I'm going to, shouldn't have done that. I'm going to multiply the x's, which would be negative 6, multiply the y's, which is negative 3. Always add them together, negative 9. That's your dot product. It's just one number. Let's try one more. Dot product of w and v. That's those 2. So all I'm going to do is multiply by x's, which is 0, multiply your y's, which is 4, add them together always, and you get 4. That's all you do for dot product. Multiply the x's, multiply the y's, add them together. And here's why we're doing that mainly. To find the angle between two vectors. If you have two vectors, especially two component vectors, to find the angle between them, all you do is this. You do cosine theta. That's how you're going to find your angle with the inverse cosine. You do the dot product of u and v. You find the magnitude of u and v, multiply those together, set up your fraction, and just punch it in your calculator to find inverse cosine of theta and get your angle between the two. Let me show you one example. Okay, so let's find the angle between those two. So I'm going to set up just like the last slide said. Cosine theta equals the dot product of the two, which means you're going to multiply your x's, multiply your y's, add them together. Find the magnitude of each one. Now the magnitude of this one would be square root of 3 squared plus 7 squared, which is square root of 58. All right, the magnitude of this one would be negative 4 squared plus 2 squared, which would be square root of 20. Normally I'd simplify that, but I'm just going to punch that whole thing in my calculator. So really what I have is this. I've got 2 in my numerator. Actually, I guess I could. On my calculator, I'm going to multiply 58 times 20, and I would get 1160. All right, so now I'm just going to hit my second cosine button. 2 divided by square root of 1160. Hit enter, and I get 86.6 degrees. So it'll be the angle that's between those two right there. All right, and guys, that's all we're doing today. Several skills, but none of them are that difficult. The main thing is keeping up with which one's which, when to do what. So, like always, we'll see you tomorrow. Answer your question. Take good notes. See ya.